Here we go. Section 1.7, solving absolute value equations and inequalities. Today what we're going to be doing is we are going to be looking at absolute value. Absolute value is a number, x, written as that right there, is a distance the number is from 0. So for example, if I have the absolute value of 7, we know that the absolute value of 7 is 7 because it is 7 has a distance of 7 from 0. If I look at negative 7, I know that the distance away from 0 is also 7. Now, distance can never be a negative number, so we can't have a negative distance. Distance is always a positive number. So anytime we take the absolute value of a number, we get a positive number in return. Example number 1, solving an absolute value equation. When we solve something like this, and I have 2x minus 5 equals 9, we know that we can have two solutions. We know that we can have either a negative 9, and the absolute value of negative 9 is equal to 9, and we also know that the absolute value of 9 is equal to 9. So I know whatever's inside of the absolute value signs, 2x minus 5, it can be equal to negative 9 because we said that this right here, whatever's inside, this can be a negative 9. So I'm going to set it equal to negative 9. I can also have 2x minus 5 and set it to a positive 9 so that there are two different results that we get. If I add 5 to both sides, I will get 2x equals negative 4. Divide by 2, and I get x equals negative 2. If I solve this side, I'm going to get 2x equals 14. Divide by 2, x equals 7. Now, if we plug both of these in, we should be able to see that it will give us the absolute value of a negative 9 and a positive 9, and our answer will be 9. So if we actually wanted to, we could plug it in. These, however, are my answers. So if I take 2 times negative 2 minus 5, I get negative 4 minus 5. So this will be negative 9 equals 9, which is a true statement. If I do 7, it's going to be 2 times 7 minus 5. So this will be 14 minus 5. And of course, we get the absolute value of 9 equals 9. Now, this was just a way to check it. We don't have to do this every time because these are our two answers up there. So on part B, let's find out the answer. So I'm going to take 6x minus 3, and I'm going to have two equations. So I'm going to have to take both of those because I'm going to set it once equal to a positive 15. And I also know in the absolute value signs that the absolute value of a negative 15 is equal to 15. So this will be negative 15. If we solve this, we get 6x equals 18, or x equals 3. There's one answer. And there's the other answer. Now, oftentimes, rather than just looking at equals, we're going to look at inequalities. So anytime I have an inequality, what I'm going to do is I'm going to have one be positive and one be negative. So I'm going to take 2x plus 7, and I'm going to write it without the absolute value signs. Now we know, just like when we had an equal sign, we can also have a negative 11. So here's how the negative 11 works. And all you have to do is always set it up like this, so that you have negative 11 here and you have the original problem like this. So now what we're going to do is we're going to solve two equations at once. We're going to solve this side and we're going to solve this side while getting things out of here so that we end up with an x. So if I do this, I will have negative 11 minus 7, which is negative 18, 2x, and 4. I'm going to divide by 2. This will be negative 9. This will be x, and this will be 2. So if you notice, the shark or alligator is eating the bigger number. The smallest number is not getting eaten, so we know that this is a good statement. This is what we call an AND statement. So anytime the bigger number is being eaten, and it goes in order so that the biggest number is being eaten, the smallest number is not being eaten, and we have an X in the middle, all of our signs are going the same way. This is called an AND statement. If we were to graph this on a coordinate point, we would have -9 here, and we'd have 2 somewhere over here. We would have an open point, open dot, because that is our less than, and we would know that these two lines come and meet in the middle. Now, this is something that we've already looked at, so we don't need a graph, but FYI, just so you know. On the next one, we're going to take it again. We're going to do 4x minus 9, and we're going to set it up just like we would without the absolute value signs, and then I'm going to set up another one over here so it's the negative, or the opposite value, and I'm going to solve it. So I'm going to add 9 to both sides. So I'm working 2 equations at the same time. So I'm going to add 9 to both sides. So 21 plus 9 is 30. Keep my sign going the same way. Plus 9 over here. Negative 21 plus 9 will give me negative 12. Then I'm going to divide by 4. So I will have negative 3. And this will be 7 1/2. All right, so the bigger number is being eaten, the smaller number is not being eaten. So we know, again, this is an example of an AND statement. Let's look at another one. So if we do this one, we're going to do this one the same way we did the other one. Let's see what happens. So if we do 3x minus 2 and we get greater than 8, we're going to set it up so that we have this problem right here, which is a negative 8. Now, if you notice right off the bat, our smaller number is being eaten and our bigger number is not being eaten. So there's something different about this. So what we're going to do is we are going to go ahead and solve this problem just like we usually would. I get negative 6, I get 3x, and I get 10. I'm going to divide by 3, so I get negative 2. Or if I simplify that fraction, this will be 3 1/3. Now, this doesn't make sense, the fact that negative 2 is being eaten and not the 3 1/2. So this does have a solution, but the solution we have to break up into 2 parts. So we're going to have x. I see the negative 2 is being eaten, so I'm going to again have the inequality sign eat the negative 2. And then I'm going to have this one over here be x is greater than 3 1/3. And rather than say an AND statement, we are going to say that this is OR. So this is an OR statement. So if I were to graph this and I had negative 2 and 3 1/3, these would be open dots. And I know x is less than negative 2 goes this way, and x is greater than 3 1/3 goes this way. So this is an example of an OR statement. But you can solve it the same way, but just realize when you get down to the end, you have to say, hey, does it make sense? If not, we're going to break it up into 2 parts. So let's try the next one. So we're going to take negative 3x plus 10. We're going to set it without the absolute value sign. We're going to have our signs keep on going the same way. And since this is a positive, we're going to make this a negative. Now, right away, you can already tell that there's something fishy going on, that it's not going to be an AND statement because negative 7 is not bigger than 7. If we go ahead and solve this, we get negative 17. And subtract 10, this will be negative 3. Divide by negative 3. Again, what we have to do, since we have a negative sign, we have to switch all of our signs, just like we did before. So anytime I'm dividing by a negative, I'm going to switch my signs. So if I do this, this will be a positive, and 3 goes into that 5 times with 2/3 left over. So I have 5 2/3. I have to switch my sign. This is an x. I switch my sign again, and this becomes a 1. Now, is 1 bigger than 5 2/3? Obviously, it's not. So it's going to be an OR statement. So I'm going to break it up into 2 parts. I usually like to write my x first whenever I do this. So I do x, and it's being eaten, not the 5 2/3. So I have to keep my inequality sign eating the x. And then I do my other one. I do x is less than or equal to 1. And we say that this is an or statement. So that is my answer. Now we have a special case for an inequality. You might have noticed one thing about all the problems that we've done so far. The number that our inequality has been related to has always been a positive number. In this case, we have a negative number. Anytime you see a negative number like this, what we are going to do is we're going to have a special case, inequality. Now, if I said I'm going to find the absolute value of any number, for example, -2, can I ever get that so it's less than -3? Well, no, I can't get anything less than that because I know that the absolute value is always positive. So this will always give me a positive number. And if I'm trying to get a positive number that's less than -3, what we do is we say that this is no solution. So in this case, how can I get a number that's less than -1? Well, I can't. So again, this is a no solution. The last type of problem that we're going to do is one where we have to do a little work to get the absolute value sign by itself. So we're going to add 3 to both sides. So I get 11 plus 2x is equal to 5. And I'm going to set my equation in this case to 2 equations. So I'll have 11 plus 2x equals 5, and 11 plus 2x equals -5. Now if I solve it, this will give me a -6. X equals -3. This will be -16, or x equals -8. So we have 2 answers, but the only difference is all we had to do is we had to get that one by itself. So in this one, I know my time is running out. I'm going to just add 1 to both sides. That way I get my absolute value sign by itself. Then I'm going to set up 2 problems. 10 minus 4x equals 2, and 10 minus 4x equals -2. I'm going to solve both of these. So I'm going to subtract 10. So this will be -8. This will be -12. This will be x equals 2. This will be x equals 3. And those are your answers.